Day 149, short circuits. A short circuit is when a current is able to take a shortcut around resistors. The current is not going through all the different parts of the contraption, it's only going through part of it. This is often due to frayed insulation or loose wire connections. The insulation, that's the plastic lining that goes around the actual metal wire. And when that gets old, it can get brittle and crack, or maybe rubbing occurs and rubs off a part. Without the proper amount of resistance, the current in the wires will increase. Remember that current and resistance are inversely proportional to each other. When one gets bigger, the other one gets smaller. So when you have the resistance getting smaller because you are skipping over some resistors, the current is going to get bigger. This causes the wires to get hot and make sparks jump across wires, or make sparks. That don't have to both happen. But these hot wires can get to be very hot, and hot enough that if those wires are touching paper or wood or carpet or something that's flammable, they could start it on fire. And we call that kind of a fire that is started by hot wires to be an electrical fire. Now when I was first or second grade, I guess it was second grade, I remember having fire alarms, and we'd do the drill going outside the school, and I noticed the teacher was turning off the lights as we left the room, and I remember asking, why do you do that? And the teacher unfortunately did not know what she was talking about, and she said, so that we don't have an electrical fire. And so in my little second grade mind, I imagined the wires up in the ceiling going to the lights, and I imagined them all glowing blue with blue flames that were all sparkly and that kind of a thing. That is not an electrical fire. Electrical fires do not burn the wires only in some kind of a special electrical flame. An electrical fire is a normal fire that will burn down your normal house in the normal way of burning the normal wood with normal floors and all of that, just as if you spread gasoline everywhere and lit it on fire. The only thing about an electrical fire that's different is how it got started. It starts with either hot wires or sparks between wires. Okay, so we have things to protect our houses from that kind of a thing, which includes a fuse. A fuse is a device that turns a circuit off in case a short circuit causes too much current. They have a very thin wire that will melt if too much current is flowing in it. Because remember, as the current gets bigger and bigger, the temperature is going to get higher and higher as well. It eventually gets high enough to melt the wire. So in my first house, it was an older house, we had fuses like this. And so we'd have different circuits in the house. One circuit would go through just the bedrooms, another circuit would be just for the kitchen, another circuit would be just for the dining room, and each one of those circuits would be wired up to a little socket in a fuse box, and in each socket was something that looked like this. This is pretty much life size here, just about an inch or so across. And it had a regular old light bulb screw mechanism on one side. The other side had a clear window that you could see a little wire through. And so I remember one day, it was on a summer, the air conditioner was going, my microwave was going, and I was vacuuming at the same time. And suddenly all of that turned off. So I went to the fuse box and I looked, and sure enough, the wire here was broken. So you unscrew this one and you put in a new one. Hopefully you have a box of spares right next to the fuse box, and then everything works out just fine. You just turn off one of those devices, the air conditioner or the microwave or the vacuum. You turn one of those off so that you're not using as much current at the same time. For smaller appliances, stereo equipment, scientific equipment, that kind of a thing, you might see a little item like this. And again, this is about life size. And you can see the little wire on the inside there, and the silver caps are the terminals, so you plug this in and that will protect that instrument from too much current. Cars will have fuses, and they look like this. Again, life size, about that big. And you plug this into a little outlet, and you see a little wire there. And so if too much current flows through someplace, you don't fry out the whole car, you just fry out this one little fuse. My van right now has a fuse problem. I can't hook up a trailer without it blowing a fuse and the brake light's not working. So I need to have my brake lights working, so I just don't pull a trailer anymore. Figuring out electrical problems in a car can be very, very tricky, which takes lots of hours for the mechanics to figure out. And so that means it costs lots of money to try to fix an electrical problem. I'd rather just simply not pull the trailer. Number 8, a circuit breaker has the same job as a fuse. When the current gets dangerously strong, an electrically powered magnet is run on the same current as the dangerous one. The magnet then gets stronger, and it's able to then eventually pull a switch to stop the current. So the nice thing about this is that you don't have to have spare parts on hand all the time. What happens is that you have this kind of circuit breaker box. Open the door and you'll see all these little switches. They're sort of like light switches. They're a little bit more stubby than what's on your wall in your bedroom. And the light switches, when they are activated by the magnet, will just move a little bit, not all the way across. So at first glance, it's not obvious which one of these switches has been activated. It only moves, maybe a quarter distance around or a half a centimeter, that kind of a thing. So in order to reset this, first of all, you have to go up to the circuit and unplug something so that you're not pulling so much current. But apparently, there's a little risk, a small risk, of a bright flash when you reset these things. So once you figure out which one of these switches has been activated, you put your fingers on it so that you're grabbing the right one, but then you close your eyes and you push it all the way over to one side and then all the way back to the original side. Again, apparently there's a small chance of a very bright flash when this happens, and so closing your eyes is a simple precaution. Okay, next, a GFCI outlet is one that has its own circuit breaker. I believe that these letters stand for Ground Fault Circuit Interrupter. I think that's right. I might be wrong. But you can tell that a circuit is this kind, an outlet is this kind, because it has two buttons on it. They have this by law whenever you build a new house or do renovations on an old house, in areas like a bathroom and a kitchen, places where something might fall into water. In the past, there have been enough people who, let's say they were taking a bath and they wanted to watch TV or listen to a radio, and so they had it close enough to the edge that the television slipped in or the radio slipped into the water and electrocuted the person. And so they have these circuit breakers on just that outlet, and they can turn off the current fast enough to prevent you from dying. Grounding. Short circuits can sometimes cause charges to build up on the outside of devices. And this would be dangerous then to touch, because then you get shocked. To prevent this from being dangerous, grounding wires are used to carry charges to the dirt outside. That's why we call it grounding wires, because it actually physically connects the wires to the ground. Some plugs have 3 prongs because the round hole is the ground wire. So when you plug in to this hole right here, there's a wire connected to that socket that goes through your walls to the floor outside the house, to a cable about as big around as your pinky, and that goes to a stake that goes in the ground. And so the charges can flow to the earth and dissipate in the area, and everything is harmless. My brother was doing a household renovation. He was rebuilding his house, and he wanted to pull up that grounding stake. And I figured, okay, great, I can do that, no problem. And I started to dig around it and pull, and nothing moved. I dug a little bit more, and nothing moved. I got a car jack out and slowly started to use the car jack with a bunch of contraptions to try to get this thing out of the ground. It turns out that this grounding stake is about 10 feet long, and I was amazed by that. And apparently, my guess is that they want lots and lots of contact between this grounding wire and the earth, so that there's lots of places where the wire is touching dirt particles and it can dissipate the charges very effectively. Okay, anyway, the left prong of these plugs, you'll have noticed probably, is a little bit wider. Oops. This outlet right here, a little bit wider than that one. And that's because that's the neutral, which is very much related to being a grounding wire. And that's the end of the notes.